Question 4a, the bar chart shows the power of 3 different electric hair dryers. So power is in kilowatts, that's key to note. And which one is the most powerful? The most powerful one here would be A. Which one of the hair dryers, A, B or C, would transfer the most energy in 5 minutes? Well, remembering that energy is equal to power times time, and we're being asked to do energy. If the time is fixed at 5 minutes, then clearly, if we just did this very quickly, 1.5 times 5, 1.0 times 5, and 1.25 times 5, clearly that is the biggest out of these 3 numbers. The answer is A. A small travel hairdryer has a power of 500 watts. Draw a 4th bar on here to show the power of the travel hairdryer. Now, remember, we're working in kilowatts. Yeah, so therefore we need to take 500 and divide by 1,000. 500 divided by 1,000, okay, is 0.5. So if we go here, we'd need to draw a line going across with a ruler. And it doesn't matter if the bar is exactly the same size. I would quickly shade that in and add a D so that we're clear, and that would be sufficient for 1 mark. A family shares the same hairdryer. The hairdryer has a power of 1.2 kilowatts. The hairdryer is used for a total of 2 hours in each week. Calculate kilowatt hours. So we've got kilowatts, we've got hours, and we're trying to calculate the energy. Remember that equation, E equals P times T. So if we've got power in kilowatts, and the time in hours, we're going to get an answer in kilowatt hours. So it's quite a simple one. Just check with the physics sheet here, the equation sheet. This is the equation we'll be using here, E equals P times T. So to get an answer in kilowatt hours, all we've got to do, E equals P times T. E is therefore equal to 1.2 times 2, which is equal to 2.4. 2.4 kilowatt hours. Done for 2 marks. Right, really important that you notice this. This is 4B part 2. Okay, so we've just done 4B part 1. So these questions are linked because they're part of the same question. This is part 2 of question B, so they are linked. Now if we're going to work out the cost, okay, which is what we've been asked to do here, calculate the cost. The cost is equal to the power used times the cost per unit, so power, that would be units used and the cost per unit. Okay, so cost is going to be equal to our units used, which on the last question was 2.4 kilowatt hours. Okay, and this question tells us that the cost per kilowatt hour is 15p. Now we're being asked to work out our answer in pence. Can you see that? Our answer is to be worked out in pence, so I can just leave it as 15p. So 2.4 times 15, let's just check that in the calculator, and we should get an answer of